Why nitrogen purging in electrolyzers? Imagine a massive industrial electrolyzer membrane being carefully fed with brine and caustic solutions to start the process. As the polarization process begins, a mysterious tension builds up within the membrane, creating a critical moment for the system. But wait, there is a hidden danger. If oxygen and hydrogen gases mix during this phase, it could lead to a disaster. This is exactly why we introduce nitrogen purging, acting as a protective shield to push out any trapped air or gases. The nitrogen flows through the system, safely clearing the path and ensuring that no explosive mixtures remain before full operation. Now the system is safe, stable, and ready for high-efficiency production without any risk of explosion or membrane damage. The secret of electrolysis power. In a high-tech lab, a scientist prepares a powerful electrical system to test the limits of polarization and voltage. The voltage is carefully increased, reaching a critical range between 1.6 and 1.8 volts to trigger the reaction. Suddenly, the current surges powerfully, hitting a massive flow of 40 to 60 amperes through the system. Inside the brine solution, the intense electrical energy begins to break apart the chemical bonds of the saltwater. At the brine side, tiny bubbles of oxygen start to generate rapidly, creating a shimmering effect in the water. Simultaneously, hydrogen gas begins to form and rise, completing the powerful process of electrochemical generation. The secret of chlorine generation. Inside the industrial plant, the engineer carefully monitors the system to ensure no explosive mixtures form during the process. To keep the environment safe and stable, the team continuously performs nitrogen purging to push out dangerous gases. The engineer keeps a very close eye on the voltage meter, knowing that a specific limit must be reached. The tension rises as the voltage climbs higher and higher, slowly approaching the critical threshold of 2.1 volts. Once the voltage finally hits 2.1 volts, the chemical reaction triggers and the chlorine generation process officially starts. The engineer concludes that maintaining a strict balance of polarization current and voltage is the only way to ensure safety.